by popular request, we're going to look at, this is number 6 from the previous worksheet. I had done this one in a different way, but I thought I would maybe do it in a little bit different way. Maybe it's a little bit less number of things to keep up with. So there'd been a number of people to ask if I could kind of re-explain or explain it in a little bit more detail or a different way. How can they graph tangent? And so I want to try to minimize the number of steps that we take. Now, some things are kind of required because that's just the way it is. And so we're going to go ahead and figure out some of the pieces, right? So my A is 3, my B in this case is 1/2, my H is going to be negative 11 pi over 6, and my K is negative 2. Now, if you watched that previous video, then you've seen me do this one in similar ways, but I'm going to kind of talk about the x-axis and how I can kind of maybe streamline that process and make it a little bit more like what we did with sine and cosine, so we're not having to learn so many different ways, right? And if you kind of get both ways, then you can decide which one you feel is more helpful, and you can kind of focus on that. All right, so the first thing we're going to do is we're going to write down our period. Right, I'm always going to write this out just in case I do something wrong in the graph. I can at least get some points on these kinds of things, right? So 1/2, or pi divided by 1/2 is going to be 2 pi. My phase shift is equal to h over b. Right, so negative 11 pi divided by 6 divided by 1/2. Remember, that's just going to be 2 over 1. My 2 and my 6 can be reduced. 2 goes into 2 one time, 2 goes into 6 3 times. So we end up getting negative 11 pi over 3 as my phase shift. Then, of course, my vertical shift is easy. That's going to be negative 2. And so I'm going to go ahead and kind of throw in my horizontal value, my x-axis. Remember, now this is down at negative 2. If I were actually working on a coordinate plane, then this is down at negative 2 on the y-axis. I'm going to go ahead and put in the center, because with tangent we always work from the center left and right, right? So we're going to start with our center, and that center is always going to be my phase shift. So negative 11 pi over 3 is always that center part. Now, if you remember, when we worked with sine and cosine, we always talked about using the increment between the different marks on my x-axis, right? So you've got these values here, and the increment in between, like how far apart are these numbers, is exactly the increment. And we always break our period up into 4 pieces, right? And so we're going to have 2 pi divided by 4, which just turned out to be pi over 2. And that's my increment. So if I were to add pi over 2 times and subtract it 2 times to the value here, so if I were to add it once to here and then add it again, if I were to subtract it 2 times, I would get these values. And that's kind of where we're going to go with. I want to use my increment to just get that. I'm not going to do any kind of extra averaging or anything like that. I'm just going to start out by saying 11 pi over 3 plus pi over 2, right? And I really have to do this one time to get the common denominator. And then getting the rest of them, it's a simple addition and subtraction problem. So we're going to convert this into sixths for both of them, because that's going to be my common denominator here. Multiply that one by 2. This is going to be negative 22 over 6 pi and 3 pi over 6. So if I'm adding, and when we go this direction, we're going to be adding. When we're going this direction, we're always going to be subtracting. It's just a number line, and that's how you move along the number line. So if we add negative 22 pi over 6 plus 3 pi over 6, that's going to get us negative 19 pi over 6. So we're going to kind of put that in negative 19 pi over 6 here. And now I'm really focused on just the part that I'm doing right here. Right now we're going to be focusing on this unit. I may be able to reduce some of my fractions. I can't do this one yet, and I may not be able to do any of them. But if I can, it's really important to keep this. Now this is not in lowest terms because I want to be able to add very easily. I'm going to keep it like this, and if I have to reduce any, I'm going to keep in mind what it was before so that I can continue to add as easy as I can. So here again, let's add a pi over 3 over 6. So I'm really just adding 3 to 19, right? So if we work that out, you're going to get negative 19 plus 3. That's going to give you negative 16 pi over 6. But that's going to reduce. You can cut that in half. They both have a factor of 2, so negative 8 pi over 3. If I go back the other direction, we're going to be subtracting. So negative 22 minus, I'll write that down, negative 22 pi over 6 minus 3 pi over 6. All right, so this way we're going to go backwards. This is going to be negative 25 pi over 6. That won't reduce. If I subtract it again, I'm going to get negative 28 pi over 6. But that definitely reduces by a factor of 2 as well. So we get negative 14 pi over 3. And if you remember from my previous example of this exact problem, these are the same numbers we got last time. Okay, I'm going to go ahead and add in those asymptotes because we know where they go. They always occur on the edges. So the asymptotes fall here. And I know my points. I know that my y-axis, I like to put the y-axis where it is on 0 on the x-axis here, right? But we don't quite get there, so I'm just going to put it over here on the edge. So here's your y-axis. We know that this is negative 2. I'm going to add my a value, so that's going to go up 1, 2, 3. So negative 2 plus 3 is 1. Negative 2 minus 3 is going to be down here at negative 5. Okay, and let's add in our points. We know that we have a center point here. We have a positive tangent, so it's going to be going from the bottom left, right? So I'm going to kind of line up my values here. So we're going to basically, I'm going to go across to this value, and we're going to go down to it lines up with my negative 5 and put a point right there. And so put this point here, and we do the same thing at the top. We're going to go over to the middle one here. We're going to go all the way up to where we have the 1 and put a point there. Right, and it kind of looks like it's a diagonal line, but we know it's curved, and so it's going to go up like this towards that asymptote. Be careful not to pass through the asymptote. And that's it. I hope that was a little extended. Like most of you won't take as long to do that. But take that for what it's worth. Just to kind of recap real quick, we found our values real quick. We found our period, we found our phase shift, and our vertical shift. Remember, tangent does not have amplitude, so we're not writing it down. Now, the a value does play a part, right, when I find my y-axis values. The third, the thing we did find that we didn't do last time was this increment, right, which is exactly how we did it with sine and cosine. With sine and cosine, we tended to start here and kind of walk our way to the right. With tangent, we start in the middle, we add 2, and we subtracted 2. I was using this, my increment, that had been adjusted to the common denominator of 6. So I added that value 2 times. I subtracted it 2 times. I reduced those values if that were possible, right? That's not a super crucial thing, but it's important that we do that. And then I added my points in the correct places by checking to make sure that I didn't have a negative sign. If I had to put a negative sign, then it would have been from the top left all the way down to the bottom right. And this is tangent. I hope this gives you a little clearer picture of how to graph tangent. This is always applicable to any type of tangent graph. The one thing that I would say is that if you don't have a phase shift, then tangent's going to start at the y-axis. It'll start at 0, right? And I can add it 2 times and subtract my increment 2 times from 0. So that would be nice. It's also a good thing to note that if it starts at 0, then my right side and my left side would be mirror images, and you'd have a positive value here and a negative value, and they'd be the same numbers. Anyway, hope this helps. If you get any questions, let me know.